Okay, is the screen visible to everybody?
Green. Yes, the screen is visible.
Okay, so okay, it was a presentation done very quick time, so there may be some flaws and other stuff. Okay, I can see you over here, but don't worry. Okay, we'll get the gist of it, and then I will share some material as well with you guys, so it can help you to go forward in your life with big data. Okay, so okay, am I audible?
Yes, you are audible.
And in the screen still visible, huh?
Yes, screen is also visible.
Okay, so what we're going to do is that we will do an overview and today's as a agendas, but I don't think I can go up to the examples. So what I will do is that I will share some website with you, and if you need another day, we can speak about it, and we can arrange another day to do some examples. Okay, so this is basically the agenda of today. So why we need big data? The first thing is that you see anything you are learning, the first thing you ask yourself why. You see, before computer there was world, there was banks running, there were businesses running. So why computer? So that is the thing. Anything you want to learn in your life, the first thing you ask yourself, why I need to learn this? If you can get the answer, 70% of your learning is done. And the 30% remaining is how to do that. So the same thing of big data. Okay, if you see that the what is the main problem we are facing, like if you see the first slide, the 90% of all data was created in the last 2 years. Okay, I will say maybe 3 years. It is a little bit old statistics, which I did acknowledge at the end of the presentation. You will see that. Okay, so with the advancement of the social networks, okay, if whatever questions you will be having, you can note it down, and I will go through it at the end of the presentation. Okay, so you can see about that the world data, like they say that from the beginning of the time or beginning of the civilization, the amount of data has been doubled in the last couple of years, 3 4 years, with this WhatsApp and Facebook and Messenger and Twitter. Excuse me. Okay, so all these things, and the problem with that one is that most of them is unstructured data. Like it is very easy to understand what is the difference between a structured data and unstructured data. Like when you use a relational database like a table or something, a relation, then what you are doing, okay, the player name is, for example, Ronaldo, plays for the country Portugal. He's a striker, so it comes as a structured data. Like the tuple is Ronaldo, comma Portugal, comma striker, comma Juventus, comma etc etc. But when you write in a messenger or in that or in a Twitter that the player hash Ronaldo playing for hash Portugal, okay, is brilliant, or he's hash brilliant, or somebody writes the hash Portuguese, hash Ronaldo plays for hash Juventus, is hash excellent. Both of them actually means the same thing. But the problem is this is the all both of them are unstructured data, and it becomes very difficult to do a statistical analysis. Like for example, if I take a opinion of 1 million people, and I want to see that how many people is saying good about Ronaldo, how many people are saying that okay, he's overrated. So I cannot really do it with the Twitter feed or something. But if I get a relational database, a table or something, it is much easier. I can just count the number of records and count how many people has. I just use a dictionary file, excellent, brilliant, good, okay, overrated, not that good type of things. And I can match the dictionary and easily come up with the statistics. And the 85% of people are saying, no, he is good or he is brilliant. Okay. So The but with this, I really cannot do until we can convert unstructured data into a semi-structured or a structured data. I cannot do that. So the problem with that is decision making for the companies. Okay, they are doing a 360-degree overview of their clients. Like wherever you are there, they are following you. But the problem comes is that when you are messaging something or tweeting something, then you are not using a structured data. So this unstructured data is very difficult to process and to come up with a strategic decision for the business houses. Okay, so only 20% of the data in today's world are basically the processed by the traditional system, like a say a RDBMS or something. Okay, so you can see the statistics. Okay, so you can go to the next slide. So this is the problem. Okay, so we are coming here. Okay, a growing and interconnected world. Like you can see yourself in a mirror and you can see that you are using Google, you are using Facebook, you are using Twitter, you are using WhatsApp. Okay, then when you are going out, you are using a GPS, you are using your credit card. Okay, you are using a lot of RFID tags today. So how I am going to follow you? Okay, so you can understand the difficulty. Okay, like how I am going to, like, you yourself is generating gigs of data in a month. Think of the population of the world. Think of how many people are using this type of devices and this type of cards and other stuff. Okay, other similar stuff. So it becomes extremely difficult to analyze the thing because it is working on huge amount of data. Okay, so the main characteristics of the big data is the three, we call it the 4 V's. That is the volume, the velocity, the way they're going. Okay, the different variety and the veracity. Okay, you can see over here that the cost efficiency processing of growing volume has gone 50 times more. Okay, from 2010 to 2020. Like if you think of a computer you were using 2010, it will be very difficult or very time consuming for you to run in the today's world. Okay, so you can see that, okay, it becomes entirely very difficult with the you go to the credit card, you go to a shop and you tap your card. Okay, can you imagine that who is going to, like, how fast, how many people are using the same bank card at the same time and tapping everywhere everywhere in Calcutta only? Okay, or Kolkata, sorry. Okay, তো বোঝা যাচ্ছে তো জিনিসটা খুব খুব মানে প্রবলেমেটিক হয়ে যাচ্ছে. Okay, as I told you earlier that 80% of world's data is unstructured today. Okay, so the main problem where the thing comes over here is that 1 in 3 business leaders don't trust the information they use to make decision, and it becomes extremely difficult for a company. Okay, because a wrong decision making can destroy a company. Okay, I can give you a small example. When I was back in India, okay, and I think it was in 2005 or 6, we used to use, no, a bit earlier, in the late 90s. Many of you were not born that time. Well, they used to use pager. Pager means that there was no mobile devices, like no mobile phones that time. Okay, they were there, but very expensive. Like you have to pay, I think, 10 rupees or something for an incoming call. So that time there was a thing called pager. Like it is also a device, like how they can pinpoint you. But what you do is that you call the pager company and you say that with this particular pager number, I want to send this message, and they do it. Okay, so you can be discovered within a million using a pager. So Philips India invested a huge amount of money in coming up with a new type of pager, and the pager became obsolete and mobile took its place. They lost billions. Okay, so a proper strategy making is very helpful for a company, and a wrong strategy can destroy a company. So it's very difficult. Now, what about the cost? Like, if you remember, like, people used to go for supercomputers, like one computer with a huge computing power. Okay, a huge amount of RAM, bit of cache. Okay, and then they used to use that in order to compute faster. Okay, but what happened later is that the amount of data became so big. I will come up with a bit of statistics just now. Okay, that it becomes t- next to impossible to just imagine that one supercomputer is handling Facebook of 2 billion plus users. You have to give your username and login, and you have to come after an hour or 2 hours or maybe a day to see whether you are logged in or not, because they have to search you out of 2 plus billion records. Okay, so you can understand that a parallel computing is required. Like, many a processor will help to do one single computing. Okay, so these are the commodities of hardware enabling the new analytics. That is the low cost compute platform. Okay, that is one petabyte of Hadoop cluster. I will come to what is Hadoop. Okay, that is what we are going to do today. Okay, can for approximately 1 million users they can handle. Okay, and naturally the up and running with the cluster in hours, up and running with cluster in minutes for cloud. Okay, pay what you use. Many of people are using these things. If you know that, okay, the middle tier, the AWS, the Amazon Web Services, the banks are using that. They are going to cloud nowadays, though they need the security. Banks need a lot of security. Okay, so but still they are going to cloud because that is the only answer. Okay, so the five main thing is the big data exploration, that is to visualize, understand all big data to improve decision making. Okay, as I told you, that decision making is the outmost. Like, you go to a shop, for example, departmental shop. I forgot the name. There is a Walmart. No, এই দেবরূপা, ওর নামটা কি রে, যেটা আমি যেতাম, কি এস দিয়ে নাম ছিল রে, ভুলে গেছি। এনিওয়ে,
Spencer, no.
স্পেন্সার, হ্যাঁ, ওদের তো চেন সুপার মার্কেট।
Yes.
হ্যাঁ, এবার স্পেন্সার কি দেখলো যে ওদের যে কম্পিটিটর, ঠিক আছে, ওরা তুমি গিয়ে 1 কিলো চিকেন কিনলে, দ্যাট গোজ ইনটু দেয়ার রেকর্ড। সেই 1 কিলো চিকেনটাও কিন্তু ওদের রেকর্ডে চলে যাচ্ছে, এবং ওরা বছরের মানে মাসের শেষে অ্যানালাইজ করছে যে স্পেন্সারের একটা কোনো কম্পিটিটর, সে XYZ ইজ আ কম্পিটিটর অফ স্পেন্সার। ওরা তখন ওই কি যেন আর একটা আছে, যেটা ওই এতে ছিল রে, ওই গড়িয়াতে ছিল, চাল ডাল পাওয়া যেত।
Big Bazaar, no.
হ্যাঁ, বিগ বাজার। তো ওরা দেখলো যে বিগ বাজার আমাদের থেকে এগিয়ে যাচ্ছে চিকেনে। তো ওরা কি করলো তখন, যে চিকেনের জন্য একটা স্পেশাল দিয়ে দিল। কিন্তু এই যে স্পেশাল গুলো আসছে, ইটস নট লাইক ওদের মালিকের একদিন সকালবেলা মনে হলো, ওকে, লেট মি অ্যাপোলজাইজ ওয়ান থিং, আমার বাড়িতে দুটো সারমেয় আছে, তারা মাঝে মাঝে একটু চেঁচাতে পারে, ঠিক আছে। তো এনিওয়ে, তো ওরা দেখলো যে বিগ বাজারের থেকে ওরা একটা স্পেশাল দিয়ে দিল। তো এরকম নয় যে when they're giving the special or giving a good discount on a particular item, it's not that they're doing something good for you. They want to beat their competitor. তো এইটা আসছে কি করে? Can you imagine, মানে কটা লোক স্পেন্সারে যাচ্ছে at a particular moment, and each and every transaction is recorded in the data warehouse so that they can analyze it, okay, in future for making decisions. So this is just a big data exploration example. তো এক্সিস্টিং কাস্টমার দেখবে তোমরা এখন সব জায়গায় কার্ড দিয়ে দিচ্ছে তোমাদের, তোমরা কি, আর যারা কার্ড হোল্ডার তারা বেশি বেশি করে ডিসকাউন্ট পাচ্ছে। লাইক, তুমি স্পেন্সার কার্ড আছে তোমার কাছে, সো ইউ গো দেয়ার এন্ড কার্ড হোল্ডার গেট 5% মোর ডিসকাউন্ট দেন দ্য নর্মাল কাস্টমার। ওয়াই? বিকজ দে ওয়ান্ট টু ফলো ইউর ভিউয়ার। তুমি, ওরা যদি দেখে যে ইউ আর নট কামিং টু স্পেন্সার ফর couple of months or something, they find it out. They've got software running in the servers, and they will automatically send an email that for particularly for you, you are getting this discount. এরকম না যে ওরা তোমায় খুব ভালোবাসে, ওরা কাস্টমার লুজ করার ভয় পায়। Okay, so okay, and obviously the security, the risk, okay, fraud monitors. Okay, as I told you just now that AWS is going, like the banks are going in cloud, so the cyber security in runtime, real time. Okay, এইসব ব্যাপারগুলোই আমি অতটা ডিটেলসে যাচ্ছি না। Okay, and I think the last point is very important. Okay, is the data warehouse augmentation. কারণ তোমার সমস্ত রেকর্ড, every record of a client is being stored in the data warehouse. Like for example, MRF টায়ারের একটা সাপ্লায়ার আছে, সে কতদিন কি সাপ্লাই নিল, কবে কবে কি সাপ্লাই নিল, দে ফলো দেম। আর তার যদি দুম করে একটা মানে কমে যায়, then MRF is worried. They will follow it up. Why this guy was taking 5,000 tires a month, now he's taking 2,100. So everything like business is a cutthroat competition. Okay, তো আমরা এই ব্যাপারটা একটু দেখবো যে কিভাবে আমরা এই জিনিসটাকে একটু সহজ করে নিতে পারি, like we can make it a bit easier. Okay, and digestible actually. আচ্ছা, তো জিনিসটা কি হচ্ছে এখানে দেখো, যে মেন ডিফারেন্স is we want to track the data on the go, whereas আমাদের conventional RDBMS, যেটা এটা সার্ভার ক্লায়েন্ট সার্ভার আর্কিটেকচারে চলে, okay, they will get the data and then do the analysis. But what we will do over here is that we will catch the data on the run and we will do the analysis over there. That is a main, if anybody asks you what is the main difference, and I will share later, but I don't think I will have time today, but I will share later which is the main difference between a conventional RDBMS and the so-called NoSQL. Okay, don't think that NoSQL means it's not only SQL. Okay, so I will give you some. Later on. I will share some slides on that one. Okay, I will give it to Devrupa and she can share it with you. Anyway, so this is the main thing. We will come into a bit of detail a little bit later. Okay, the ingestion and real-time analytics zone, which is a stream which is coming. Okay, you can see over there that it's not a rainbow; it's a Wi-Fi. I just got a WhatsApp yesterday that kid is telling his grandpa, it is not a rainbow, it is a Wi-Fi symbol. Okay, anyway, so you can see whether the different connectors is your Facebook, your WhatsApp, your all these things are different. Okay, then this is a very important thing which you call it is a map reduce. That is a particular, I won't say it's a component. Okay, which will do that thing. Okay, just hold on 1 minute. Please, sorry, I'm in a webinar. I can't answer you now. Okay, sorry guys, apologies. Okay, so you can see over here that everything comes to this. Okay, and we will learn a little bit more about this one. Okay, and you can see over here that what they're coming up with finally, like a BI, a business intelligence reporting. Okay, or a predictive analytics. Okay, you know what is a predictive algorithm is, like for example, your weather forecast. Like they say there is a 70% chance of rain. Like how? What they follow is that they follow a huge database. Okay, like what happened, say today is the 26th of June. So last 20 years, 26th of June, did it rain? No, yes, no, yes, no. Then come up with the different weather conditions, like what was the wind type, is it a northwesterly or something like that. They will calculate another 48 to 50 different parameters, what happened. And then they see that, okay, if like 80% of this parameter matched, it did rain. And they come up with this predictive analysis that, okay, it can have a 80% chance of rain in this scenario. Because in this scenario, 80% of the time, in the history, it did rain. It's not like 80% chance of rain means it is a definite thing. Okay, but it is a predictive algorithm. Again, you can see over here that it is a huge amount of data they have to analyze. Share market, okay, like a prediction. It can come up with a prediction. A prediction cannot be 100% true all the time. Okay, so sorry. So you can see that the visualization discovery, like a DSS system, a decision support system. Okay, so these things are all coming up with the huge amount of historic data that is stored in your data warehouse. Okay, but the problem will come now that how Hadoop or big data solution helps you to handle that huge amount of data. Okay, so these are basically the different type of platform. Okay, the manifesto platform manifesto that the okay, I'm not spending much time on this one. You can Google these things. Okay, so we will go directly into the main component of a big data, which is the Hadoop architecture. Okay, so these are the main points we will be doing. Okay, the comparison with RDBMS I'm not doing today. Okay, I thought I will do so when I was preparing the slide. I just did it, but anyway, but we will be focusing mainly on the HDFS, which is the Hadoop distributed file systems, and we will mainly discussing what is a MapReduce. Okay, these are the two main component of a Hadoop architecture. Okay, so you can see over here. Okay, this is a very important thing. Okay, the amount of CPU speed increased. I'm only going up to 2010, which is nearly say 10.5 years back. Okay, the amount of memory increased. Okay, the disk capacity, the latency time. Now, if you see in the blue box, how long it will take to read 1 terabyte of data at 50 Mbps. Okay, if it is one disk, it is 3.4 hours. It's just an example. If it is 10 disks, it is 20 minutes. You can calculate. I think you have done this thing. Okay, in 100 disks, it will take 2 minutes. But if it is 1,000 disks, can you imagine? So if you distribute your data, this 1 terabyte of data into 1,000 disks, like for example, you are watching a movie. Other than keeping it in the hard drive alone, though you're using a Core 7 processor or something, so 7 of them, like 7 times 80, that is 560 Mbps. But still, some cores are always occupied by the operating system. So I'm not going into that details. But you can see over here that if you can distribute, say when you are watching the first 5 seconds of the movie, the another 999 disks are ready with your stream. So when you are, just think of YouTube, they're using one disk and you are streaming from there. It's just not possible. But if you are using 1,000 disks and 1,000 processors are helping you, then it is possible. I think I will answer your queries later on. Okay, but you can see one thing, that if you increase the number of disks, okay, then you can get the data much quicker. That is the bottom line of this slide. Okay, so the answer is, as I told you, is a parallel processing. You can see the picture. There is a lot of dumb nodes. Like these are basically no, sorry, not dumb nodes. Nodes without a monitor or something. Okay, like it's a lot of nodes over there. Each of them has got a processor, and they are helping you. Okay, we call it the name node. Later on, you will see that, to feed the data from different sources. So each of them, just hold on, Mishti, no. So you can see that, okay, at the end of the slideshow, I will show you these two idiots over here. So you can see, you can go through the slide. Okay, you can put your points down. যা যা একটু প্রবলেম হচ্ছে বা অসুবিধা হচ্ছে একটা পয়েন্ট আউট করে রাখো. I will come back to you. Okay, so you can see over here that, okay, what are the benefits? Like আমার যদি আরো সাইজ বেশি দরকার হয়, আমি আরো 4টে নোড লাগিয়ে নিলাম. That is scalability. ঠিক আছে, কিন্তু তুমি একটা হিউজ সুপার কম্পিউটার ইউজ করছো and you still see that, okay, there is a problem with space. It's difficult. Okay, so you can see over here the fault tolerance, very very important. The reliability, তোমার একটা নোড বসে গেল, তোমার কিন্তু সিস্টেম বসলো না. Okay, so that reliability of the fault tolerance, very very important. Okay, so we'll come to all these things later on. Okay, so Hadoop একটা মজার গল্প আছে, how Hadoop started. 2007 2007 আমার নামটা ভুলে যাচ্ছি রে, লেখা উচিত ছিল। তো হাডুপ যিনি শুরু করেছিলেন ইয়াহুতে চাকরি করতেন। তো he got the idea, then when he came back home he said no, this is a brilliant idea, we can implement that. তখন ও ভাবছিল যে what it will be called or what name shall I give it to. তো দেখলো ওর বাচ্চা মেয়েটা একটা হাতি নিয়ে, ওই খেলনা হাতি সফটওয়্যার নিয়ে খেলছে, and she used to call that toy Hadoop, so he gave the name Hadoop. Okay, so it's a funny thing behind the history of how the name Hadoop came. So it is an open source software. তুমিও ইচ্ছে করলে you can put some coding and send it to them. Okay. The main three sub projects is the MapReduce, যেটা আমি আজকে একটু discuss করব, which is very important. Okay, and HDFS, that is the Hadoop distributed file system. Hadoop common এ আজকে আমি খুব একটা যাওয়ার time পাবো না, so maybe I will give you some material to read, some websites as well. Okay, so there are several Hadoop related projects which is going on. Okay, HBase, Zookeeper, Avro, okay, আরো আছে, Pig আছে, আরো আছে. Okay, so it is meant for heterogeneous commodity hardware. এটা কিন্তু একটা মজার জিনিস, it's a very funny thing. What is a commodity hardware? That means low cost hardware. ঠিক আছে, তোমার পয়সা বেশি খরচা করতে হচ্ছে না। কি করছো তুমি? Now, other than getting a huge compute like a very fast computer, you are using 20 cheaper computer. Collectively they are giving you the same processing power. আমি একটা ছোট্ট এক্সাম্পল দিচ্ছি তোমাকে, যে ধরো তোমার 5 gig or 500 gig এর তুমি একটা হার্ড ড্রাইভ ইউজ করছো, which is very cheap compared to a 2 terabyte or 4 terabyte. তো এবারে you are using 50 of them. In total they will not come to the price of that one. But if you are using an older processor with that older, each and every processor is helping you to answer your query. This parallelism need to be incorporated. You will be doing faster than doing in one disk. তুমি একটা very first processor নিলে, একটা very first hard drive নিলে, but it is one processor accessing one hard drive. ঠিক আছে, মানে 15টা খুব রোগা লোক কিন্তু একটা সুমো কুস্তিকে মেরে ফেলতে পারে, like that. So anyway, so what type of transaction or what type of work Hadoop is not suitable for? Okay, যদি তোমার not to process transactions, ঠিক আছে, মানে তুমি দোকানে গেলে কিছু একটা কিনলে, ঠিক আছে, সেটা কিন্তু তুমি we will prefer a RDBMS than a big data architecture. Like we need the ACID properties and other stuff. Though ACID property is getting incorporated, but it's still not in the final stage. But এই জিনিসগুলো, এই transaction not good to work, cannot be parallelized. তোমার তো মেন ব্যাপারটাই হচ্ছে যে একসাথে তুমি ধরো একটা বাড়ি তৈরি করছো. What is a parallelism? When you are doing the foundation, মানে ভিত তৈরি করছো যখন, you can do the boundary gate, but you cannot do the windows of your room when you are doing the foundation. মানে তুমি বাড়ির জানলা তৈরি করতে পারবে না when you are doing the what do you call it, the ভিত। ঠিক আছে, তো এইটা হচ্ছে সিরিয়ালাইজেশন। লাইক তোমাকে আগে ভিত তৈরি করতে হবে, দেয়াল তৈরি করতে হবে, তারপর জানলা তৈরি করতে হবে। Whereas you can parallelize something. You can parallelize when you are doing the foundation, you can do your garden. When you are doing the foundation, you can do the boundary wall of your work. Okay, so some of the process will be parallelized, some of the process are not parallelized. So Hadoop is not good which cannot be parallelized, because the main aspect of it is that different commodity microprocessor, মানে chip microprocessor is helping you at the same time. Okay, not good for low latency data access. তুমি একজন যদি ইউটিউব ইউজ করে, not good for that. Okay, not good for processing lots of small files. They are built for big files. Okay, chup. Sorry. Okay, so scalable to any volume. Okay, as I told you that what is the main thing, that just add on and the name node just get changed, done. Okay, offload from warehouse, as I told you before, that a data warehouse goes আমি বলছি এটা 2011 এর স্ট্যাটিস্টিক। The General Motors data warehouse was 273 terabyte. I don't know how much it is right now. It's huge. মানে তুমি চিন্তা করো না যে how many people are right this moment going to Spencer or going to Big Bazaar or going to some or other chain supermarket and buying something. Each and every record getting stored in data warehouse for future strategy making. Okay, identify unique customer. Another thing. Okay, you use your credit card for the first time. They already found out, okay, this was not our regular customer. ধর এটাকে। Okay, so these are the main goal of Hadoop. You will get time for yourself to go through this. Okay, and I will give you some more of this via your teacher, and if we need, we can meet another day. It's not a problem. Okay, I'm working from home, and currently I'm on winter holiday. So okay, so these are the some of them who are using Hadoop. You can see they are very common names, and they all work with big what do you call it, big huge amount of data. Okay, so let us come to the main aspects. Okay, we have gone through a lot of stories. Okay, now let us come to a little bit of technicality about how it has been implemented. Okay, the MapReduce framework, that is how Hadoop understands and assign works to the nodes. এটা তো জানা দরকার। আমার 100 সৈন্য আছে, I don't know how to use them, তো আমার 100 কি 1000 সৈন্য থেকে লাভ কি? Okay, ফলে the first thing is that is done by the MapReduce file system. Second হচ্ছে, if I am তুমি YouTube you are uploading a video, so how to store that video? তোমার তো এরকম না যে একটা হার্ড ড্রাইভে তুমি কপি করে নিলে। Now your video is getting distributed in hundreds of nodes, so you can understand that this is a very very important thing, and they have to keep track of everything where it has been stored. ফলে তুমি কালকে যখন your YouTube চ্যানেলে গিয়ে you start watching your old video, they have to fetch it from everywhere. Okay, so the third point you can see over here, it links together the file system on many local nodes to make them into one big file system. That is one of the main objective of HDFS. Okay, so if you see that, okay, just a picture, okay, তুমি এখানে দেখো যে একের পর এক লাইন দিয়ে দাঁড়িয়ে আছে একের পর এক CPU. তো এই জিনিসগুলো দিয়ে you can see over here that they এক একটা জিনিসকে বলে এক একটা র্যাক, এক একটা লাইনকে বলছি আমি এক একটা র্যাক। ওকে, and there are different racks, মানে রো আর কলাম, ওটাকে আমরা বলছি racks. Okay, so you can see the first point, distributed, obviously, because one particular processing is done distributed among different processes. Scalable, একটা আর একটা দরকার, জাস্ট লাগিয়ে নেবো আমি, মিটে গেল। Okay, fault tolerant, very important. এক একটা file they are replicated, okay, in 3 different places. Okay, like they will be replicated 2 in the same. One good thing is that it is a commodity hardware, মানে খরচা কম, পকেট বাঁচলো। But commodity hardware has got a tendency of failing, খারাপ হওয়ার চান্সটা অনেক বেশি। So what will happen in that case is that you upload something in YouTube and it just disappears because one of the node which was handling your file gone, খারাপ হয়ে গেছে। Okay, বা দেও রেখেছে। What to do? So in that case, what do we need to do? We need to do replica. মানে when আমি যখন ইউটিউবে আপলোড করছি, then actually I'm not uploading once. It is getting uploaded 3 times. 2 in one rack and 1 in a different rack. Are you clear with me, everybody? Hopefully. I will come to your questions and queries later. Okay. Can you give me a second, please? Thank you. Mr. Roy. Mr. Roy. Mr. Roy. Thank you. Okay, the supple will eliminate the duplicates. Okay, and then you get the single result at the end. Okay, so what is the map? You give a program, you give a problem. Okay, input is split into different pieces and send মানে তুমি একটা কাজ দিলে, ঠিক আছে, কাজটাকে তুমি স্প্লিট আপ করলে, তোমার 15 জন তোমার হয়ে কাজ করছে, তুমি প্রত্যেককে বললে যে এই কাজটা করো, ঠিক আছে, কিন্তু কম্পিউটার তো অত ইন্টেলিজেন্ট না, কম্পিউটার এটাকে স্প্লিট করে দিলে বা দুজন হয়তো একসাথে একই কাজ করতে শুরু করলো। ওকে, তখন ওই সাফলিং এ করে আমি দেখবো যে না, এই দুজন একই কাজ করে আমাকে রেজাল্ট দিয়েছে, I will eliminate one of them. Okay. Okay, so you can see over here the reduce step. What it is doing is basically it is data is aggregated, reduced from the map steps by worker nodes. Okay, and multiple reductions come to a single aggregation, and you are going through that one. যদি তুমি ছবি হিসেবে দেখতে চাও, this is basically what is happening over there. Okay, I'm giving you 2 seconds to have a look at this. Okay, so we'll come back to your questions just after some time. We are nearly there. Don't worry, I won't bore you more. আমিও একসময় স্টুডেন্ট ছিলাম, আমি বুঝি কত বিরক্তিকর এগুলো দেখা। Okay, so the mappers is basically doing the map and the reducer. Okay, when you are merging, the duplicate gets eliminated and you are coming up with a single result. Okay, the shuffling phase, I mentioned to you what actually it does, but we will come up with another example, that's why I'm going a bit faster. Okay, that will help you to understand it more. Okay, so you see in this example, what they're doing is that select count name from animals who are named in tiger, lion, etc. Group by name. তো এটা তুমি যদি একটা, তোমার ধরো একটা প্রসেসরকে দিলে, তার তো প্রচুর কাজ আরো বেড়ে গেল। নোড 1 এ টাইগার আছে, লায়ন আছে, প্যান্থার আছে, উলফ আছে, নোড 2 তেও টাইগার আছে, উলফ আছে, প্যান্থার আছে। Okay, so what is happening now is that you see they will do a key value pair. So you see over here, there is tiger in node 1, there is lion in node 1, there is panther in node 1, and there is wolf in node 1. Node 2, tiger is there, wolf is there, panther is there. So if you see the next picture again, what they're doing, they're making a key value pair. Okay, what is that? Tiger, lion, panther. So each of them, just try to correlate the two pictures. So you will see over here, from there to here, they're coming down like this. Okay, now if you see the next step, what node 1 is doing, tiger 1, lion 1, panther 1. Okay, since the SQL didn't come up with a wolf or something, probably that's why they have eliminated that one. Okay, node 2 is also doing the same thing. Okay, so you can see over here now, এবার দুটোকেই পিটবো। Lucas, silent now. Okay, so you can see over here, they're aggregating them slowly. Okay, in the next picture, you will see that now they are coming up with the node 1 is panther 2, tiger 3. Because now node 1 and node 2 is shuffling with each other. So if you go to this picture, you can see that this is what's happening now. This is what's happening now. Okay. Okay, so you see now that the tigers has become, panther has become 2 in node 1. Okay, in the node 3, lion has become 2, etc, etc. Okay, so this is actually how it is working. Okay, so they are working together in, so you can see that the parallelism, like if one processor would have taken 30 microsecond to do this, then 2 processor is taking 15 microsecond. Now imagine if it is a big file and like 30 processor or 50 processor is helping you to stream that file. It will be much more faster. And I already told you about the scalability factor, about the reliability factor, because your data is not in one place, it is distributed. Okay, So hope you understand a little bit today, or hope you enjoyed the session. I won't take much more of your time. So I will share the slides with your with your guide, with your teacher. Okay, and as I mentioned earlier, that I do acknowledge that most of the statistics used are from 2018, which have changed over time. Okay, so don't take it as a Bible or as a Gita. Okay, things change over here. Okay, thank you very much for listening to me. Questions? Yes. Hey, Roy. Thank you for the coffee. Yes, nobody has no query. Am I audible?
If there is any question, students, please ask. I don't think there is any question from anyone.
Why? ওকে টেল মি অনেস্টলি, একদম অনেস্টলি বলো, কি বড় হয়েছো না ঠিকঠাক লেগেছে? একজন দুজন কেউ এটা বলো তো।
Students, please respond. Mahashita, unmute yourself and speak.
আচ্ছা,
Yes,
এই মুহূর্তে
ma'am.
আমার এই দুটোকে দেখিয়ে দিয়ে দেখো।
Please.
এই যে
Wow, they are great. Let sir know whether you have understood or not.
Yes, sir. I have understood the session. Thank you, sir. Actually, I don't have any idea about big data, so the session was very informative, and I would really like to request developer ma'am to arrange this kind of sessions very often. As we are approaching our final year, so we need to make some projects. So
why
it will
don't
be
you make
very
a
helpful for us if she arranges this kind of webinars.
I can okay, I appreciate your acknowledgement. Okay. Are utpat.
So with this,
Yeah.
we come to an end of this webinar. But before ending, let me present a memento, digital memento, and certificate of appreciation. Amlan sir, please accept this memento
Thank you very much.
digitally. I will mail you soon. And
Okay, thank you for that.
this is
But
the cert-
anybody, my email ID is there, or via Devrupa
Yes.
ma'am, you can always reach me. Okay, so I will share some more material with you. And if you want another session, it was a small session. It's a big, huge subject. If you want another session in future, just let me know a week in advance. I will prepare another session. We can go ahead with this.
Yes. So,
Okay,
sir,
thank you very.
yes, sir.
Thank you
With
very
your-
much for all of you for attending.